All right, in 5.7, we're going to look at normal distribution calculations, but this time not just using the z-scores. So the first thing you need to do is write down these 3 steps, because these 3 steps are required for all normal distribution problems, calculation problems. So you draw a normal distribution with a horizontal axis labeled and scaled using the mean and standard deviation, the boundary values clearly identified, and the area shaded. Perform the calculations. Use technology to find the desired probability without standardizing. Be sure to answer the question that was asked. And number 3, interpret the answer in context. So let's examine the continuous random variable x equals the ITBS grade equivalent vocabulary score for a randomly selected 7th grade student in Gary, Indiana. The distribution is approximately normal with a mean of 6.84 and a standard deviation of 1.55. So this is what the curve looks like. Notice 6.84 is the mean, so it's right in the middle. Number 1, the ITBS grade equivalent vocabulary score for randomly selected 7th grade student in Gary, Indiana. The mean is 6.84, standard deviation is 1.55. Okay, so what is the probability that x is less than 4? So first I want to draw my curve. Put my mean right there, 6.84. All right, what is the probability that x is less than 4? Where's 4 along this number line? Well, if 6 is here, 4 is over here. So I'm going to label 4, and I'm going to shade less than. Okay, so to find the probability that x is less than 4, what am I going to do? I'm going to use normal CDF, my calculator, and I'm going to do lower bound, which is going to be -1. You can use -1000 if you'd like. That'll work fine. And then 4. And then it asks you for the mean. We're going to use the mean from the problem, which was 6.84, and the standard deviation from the problem, which is 1.55. When I put that in my calculator, I get 0.0335. Okay? Then I have to put a sentence on this. I put it in context. So I say the probability that a 7th grader scores less than a 4 on the exam is 0.0335, or if you wanted, you could write it as a percentage, 3.35%. Either way is acceptable. Right? Then, number 2. Same problem, but this time it says, what's the probability that a score between a 4 and a 7.5? So I draw my curve. Here's 6.84. Here's 4. And here's 7.5. And I'm looking for between, so I'm going to shade the area between the 2. So in my calculator, to find the probability that x is between 4 and 7.5, I'm going to do, I'm still doing normal CDF. The lower bound this time is 4. The upper bound is 7.5. The mean is 6.84. And the standard deviation is 1.55. Right? When I run my calculator, I get an area of 0.6314, 63.14%. Then I answer it in context. I would say the probability that a 7th grader scores between 4 and 7.5 on the exam is 63.14%. All right, you could leave it as a decimal, that's fine as well. Make sure you have all 3 pieces though. The drawing, shaded, the work you put in the calculator, and a sentence in context. Last example. Right, same thing. Distribution is approximately normal with a mean of 6.84 and a standard deviation of 1.55, but the question now says, what test score would place Gary, a 7th grader, at the 90th percentile of the distribution? So 90th percentile means that 90% of the area is below that mark right there. Okay? So this is going to be a little bit different. You're going to still do second bars in your calculator, but you're not going to choose norm CDF. When you pull up second bars, you're going to look at inverse norm, which is number 3. Okay? Put an inverse norm. And notice the first thing it asks me for is the area. What area do I want? Well, the calculator always takes the area to the left of wherever you're looking for. Okay? So it always thinks this direction, like the picture's showing, the green shaded area. So I'm going to put in my area, 0.9. Make sure you don't put in 90 because you'll get an error. But I'm going to put in the area 0.90. The mean of the problem, 6.84, and the standard deviation is 1.55. All right, and it's going to tell us what score marks off that percentile, or 8.83, I suppose. Okay, so let's recap what we did here. In your calculator, you're going to do inverse norm, and the area you're looking for is 0.90. The mean is 6.84, and the standard deviation is 1.55. All right, and it gave us the value of 8.826. Now I have to put a sentence in context. So I would say Gary would have to score an 8.826 on the exam placed at the 90th percentile. All right, so those are the 3 types of problems you got to do. Now be careful on these percentile problems because sometimes it may say the problem may give you the area that's on this side of the curve, and you've got to subtract it from 1. But I'll try to model that for you when we get into class. So just read real carefully when you do these percentile problems.